Welcome to this video. This video is for CIE AS level paper practice paper 5 9709. So the first question, the time t seconds taken by 100 meters were recorded for this 9 members. So what is the thing? It is recorded for 9 members. Find the value of sigma t minus 20 and sigma t minus 20 whole square. So what am I going to do? 95 becomes 95 minus 120. Then plus 126 minus 120. Then 117 minus 120. So like that you need to subtract from each. So and add them all. Sigma t minus 120. So it becomes negative 25 plus 6. Then negative 3 plus 15 plus 0 plus 5 minus 6 minus 1 plus 16. Add them all, you should be getting 7. Now sigma t minus 120 whole square. So it's going to be 25 square plus 6 square plus 3 square plus 15 square plus 0 square plus 5 square plus 6 square plus 1 square plus 16 square. Do that, you should be getting 1213. Using the values found in part 1, calculate the variance. So formula for the variance is going to be sigma t minus 120 whole square by 9 minus sigma t minus 120 by 9 whole square. So which is going to be 1213 by 9 minus 7 by 9 whole square. So this is going to be 134 in 3 significant figures. Now next question, question number 2. So for this question number 2, this is from a tree diagram based upon tree diagram. So let's try to solve it out over there. What is being told? Megan sends messages to her friends in one of the 3 different ways. So she'll be sending it out in 3 different ways. 1, 2, and 3. So either it can be a text, it can be an email, or it can be on social media. So text is 0.3, then email is 0.2, and social media is 0.5. She receives an immediate reply from the text message. The probability is, for each of the message, the probability that she uses text is 0.3 and the probability email and so on is given. For each message, the probability that she uses text is 0.3 and the probability she uses email is 0.2. She receives an immediate reply from the text message is 0.4. Reply, no reply. Then again reply and a no reply. Reply and a no reply. Reply, no reply. Reply, no reply, reply, and no reply. Reply is 0.4, so no reply is 0.6. For email, the reply is 0.15, so no reply will be 0.85. For social media, reply is 0.6, so no reply will be 0.4. Then, given that Megan does not receive an immediate reply to the message, so she does not receive an immediate reply to the message. So probability of given that no reply. So probability of no reply in the denominator. So what is that? Text and no reply, or email and no reply, or social media and no reply. Find the probability that she message was an email. So probability of email intersection no reply. So which part is that email? Email part is nothing but what? This one is email part. So 0.2 times 0.85. Which is 0.17 divided by 0.18 plus 0.17 plus 0.2, which is going to be 0.17 by 0.55, which is equals to 0.309. Now coming to question number 3. The probability that Janice will buy an item online in any week is 0.35. So probability of success is 0.35. Probability of failure will be 0.65. And Janice does not buy more than one item online in any week. Find the probability that in a 10-week period, n equals to 10, buys at most 7. So maximum of 7. At most 7. So it can be 1 minus probability of x equals to 8 minus probability of x equals to 9 minus probability of x equals to 10. So this is going to be the answer. So let's write that one separately. Probability of x equals to 8, probability of x equals to 9, and probability of x equals to 10. Now 1 minus probability of x equals to 8, 10c 8, 0.35 whole to the power of 8, 0.65 whole to the power of 2, 10c 9, 0.35 whole to the power of 9, 0.65 whole to the power of 1, 10c 10, 0.35 whole to the power of 10, 0.65 whole to the power of 0. So 1 minus 0.004281, 0.0005123 minus 0.00002759, which gives you 0.995. Next one, find the probability that Janice buys at least one item online in a period of n weeks is greater than 0.99. Find the smallest possible value of n. So this is 1 minus q to the power of n is greater than 0.99. So 1 minus 0.65 whole to the power of n is greater than 0.99. So 0.1 minus 0.99 is greater than 0.65 whole to the power of n. So 0.65 whole to the power of n is less than 0.01. Then apply log on both sides. Log 0.65 whole to the power of n. The inequality symbol changes, is greater than log 0.01. So what does that becomes now? N log 0.65 is greater than log 0.01. So n is greater than log 0.01 divided by log 0.65. Do by calculator, you'll get 10.69. So n equals to 11. So see that whenever you apply log on both sides, the inequality symbol changes over there. Now coming to question number 4. This is from probability distribution table. So probability distribution table, let's try to solve it out further. So what is being told over here? In the probability distribution, the random variable x is -1, -0, 1, 2, 4. The probability distribution has been given over here. What is he asking? Find the value of p. We know that sum of all probabilities equals to 1 plus p plus 3 upon 8 plus 4p equals to 1. So what do I get from there? 6p equals to 1 minus 3 upon 8 minus 1 upon 4. So 6p equals to, common denominator is 8, 8 minus 3 minus 2, which is 5 minus 2, 3 upon 8. So p equals to 3 upon 8 times 6, which is nothing but what? 3 upon 16, 1 upon 16. Find the expected value of x. So what should be the expected value of x now? So let me copy this table there. P value, we got it as 1 upon 16. So I replace that one with 1 upon 16, 1 upon 16, 4 upon 16. So what is the expected value of x? Minus 1 times 1 upon 4 plus 0 times 1 upon 16 plus 1 times 1 upon 16 plus 2 times 3 upon 8 plus 4 times 4 upon 16, which is going to be 25 upon 16. Now variance of x is going to be nothing but what? This entire thing. But it is squares. So it's going to be minus 1 square, 0 square, 1 square, 3 square, 4 square, minus mean square. Mean is 25 upon 16 whole square. Simplify that, you should be getting 863 upon 256, which is 3.37. Now, next one, given that it is greater than 0. So probability of x greater than 0. Find the probability that x equals to 2. So first of all, what's going to be the denominator? Denominator is probability of x greater than 0. So what is that which is greater than 0? Greater than 0 is these three. 1 upon 16, 3 upon 8, 4 upon 16. 1 upon 16, 3 upon 8 plus 4 upon 16. Then out of that, x equals to 2. X equals to 2 is this one. So 3 upon 8. So this is probability of x equals to 2 intersection x is greater than 0. So simplify that. This becomes 3 upon 8 upon 11 upon 16, which is 6 upon 11, which is 0.545. Question number 5. Coming to the question number 5, it is from cumulative frequency graph. Ransha measured the lengths in the centimeters. She measured the lengths in the centimeters in 160 palm leaves. His results are shown in the cumulative frequency graph. Then it is being asked, what is being asked in this question number 5? How many leaves have a length between 14 centimeters and 24 centimeters? 14. Now this is 10. This is 15. There are 10 lines. 10 lines and the gap is 5. So the gap is 5 and there are 10 lines. So each line is going to be 0.5. So this is 11. This is 11. This is 12. This is 13 and this is 14. So from 14, draw the line and hit the graph over here. Again, this is 20 is the gap and how many lines are there? 5 gaps are there, 5 parts are there. So each one is 4. So this is 44, 48, 52 and 56. So it's going to be 56. 56. Then for 24, 22, 24. So 2 lines, 21, 22, 23, 24. So from 24, draw the line, hit the graph, then bring it over here. So it's going to be 144, 148, 152 and 156. It's going to be 156. So 156 minus 56. So what is going to be that? 100. So it is 156 minus 56, which is going to be 100. 10% of the leaves have a length L centimeters or more. So find the estimate value of L. 10 centimeters have a length L or more. So what about the 90%? Remaining 90%, 90% of 160. Why 160? Because total is nothing but what? 160. Equals to nothing but how much? 144. Now 144. From 144, draw the line. 144, I am drawing the line and hitting the graph and bringing it down. So we can see that it is 22. So 22 centimeters is going to be the answer. Estimate the median and the interquartile range. So 160 for the median, 160 divided by 2, which is 80th. From 80, draw the line and hit the graph. From 80, draw the line and hit it out. It's going to be nothing but how much? See carefully. It is between 15 and 16, so 15.5. So Q2 is 15.5. Now Q1. For Q1, what am I going to do? 160 divided by 4, which is 40. So from 40, draw the line, hit the graph and bring it down. It may be 12.6. So 12.6 is going to be upon 4 times 160, which is 120. From 120, I'm drawing the line and hitting the graph and coming down over here. So which is nothing but what, 17, and maybe this was 15, 16, 17, 18, 18.5. I can write it as 18.5. So what's going to be the interquartile range? 18.5 minus 12.6, which is going to be nothing but how much? 12, 6.5, 5.9. 5.9. That's going to be the answer. Sharim measured the lengths in centimeters of 160 palm leaves of different type. He drew the box and whisker plot. Compare the central tendency and the spread of these two sets of data. So the median is going to be very only less than this number is 15, 10, 15. So 11, 12. The median is 12 over here. So the median is, for the previous one we got 15.5. So median is higher. Median is higher for Ransha. And any another one? Over here, this Q1 is 10 and this is 20. So the interquartile range is 10, whereas the interquartile range is 5.9. So IQR for Ransha is lower. 2 marks, 2 points. Now coming to question number 6. The question number 6, the heights in meters. This is from normal distribution. Heights in meters for trees in a large forest is given by, is normally distributed with a mean 40 and standard deviation 8. The mean is 40 and the standard deviation is going to be 8. Mean equals to 40, standard deviation is 8. Find the probability that the chosen at random in the forest has a height less than 45 meters. Probability of x less than 45. So probability of z less than 45 minus 40 divided by 8. So probability of z less than 0.625. So which is going to be 0.734. Next, find the probability that a fair tree is chosen at random in a forest has a height within 5 meters of the, what is this, mean. Within 5 meters of the mean. So what was the mean? Mean is nothing but what, 40. So it should lie between 35 and 45. It should lie between 35 and 45. So mean is over here, which is 40. So between 45 and 35. Now we got less than 45 is 0.134. So we just now got less than 45 as 0.734. So greater than 45 will be 1 minus 0.734, which is nothing but what, 6. 9 minus 3 is 6. 9 minus 2, 0.266. So this gap will be 0.266 and this gap also will be 0.266. So we are requiring it out this part. So 1 minus 2 times of 0.266, which is going to be 1 minus 2 times of 0.266. 0.266 times 2 is going to be 0.532. So subtract it out, it becomes 0.468. That's going to be the answer. In another forest, the heights of another type of fir tree are modeled by a normal distribution. The scientist measures the heights of 500 normal chosen trees. He finds that 48 trees are less than 10. Probability of x less than 10 equals to 48 upon 500. So probability of z less than 10 minus mu by sigma equals to 0.096. So 10 minus mu by sigma, this value is not there in the table. So it is not in table. So what am I going to do? Subtract from 1. 1 minus this one is 0 0.40904. 0.904. In that case, I'm going to swap this. Probability of z less than mu minus 10. So mu minus 10 by sigma equals to 1.305. Next one, 76 trees are more than 24. X greater than 24 equals to 76 upon 500. So probability of x less than 24 will be 76 is 424 upon 500. Remaining for 500 are 424 are less than 24. So probability of z less than 24 minus mu by sigma equals to 424 divided by 500 is going to be nothing but what? 0.848. So 24 minus mu by sigma equals to 1.028. Now, what does it becomes now from here? The first equation is mu minus 10 equals to 1.305 sigma, and another one is nothing but 24 minus mu equals to 1.208 sigma. 1.028 sigma. Then add both the equations. Mu gets cancelled. 14 equals to 1.305 plus 1.028 sigma. From here, I get the value of sigma as 6. Plug in the sigma value in one of the equations. So mu minus 10 equals to 1.305 times 6. This gives me mu value as 17.8. Lastly, question number 7. In the question number 7, it is from permutations and combinations. So find the number of different ways in which 9 letters of the word toadstool can be arranged so that all threes are together, both T's are together. All the T's, O's are together, O, 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 and all the T's are together, T and T. So what is left over now? A, D, S, L. So 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units. It can be done in 6 factorial ways, which is going to be 720. Find the number of different ways in which the 9 letters of toadstool can be arranged so that T's are not together. T's are not together. That the T's are not together. So I am going to do total minus T's together. Total will be 9 factorial by 2 factorial, 3 factorial. Why this 2 factorial is for 2 T's, 3 factorial is for O's. Minus T's together. So T's together, T, 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 then it will T, T, then 2 T's, then O, A, D, S, O, O, L. So how many units? 1, 2, 3, 4, 5, 6, 7, 8 units. 8 units can be done in 8 factorial ways. 8 factorial in divided by 3 factorial. Why 3 factorial? For O's. So what does that answer will become now? 30,240 minus 6,720, which is going to be 23,520. Then part 3. Find the probability that the randomly chosen arrangement has a T at the beginning and T at the end. 1, 2, 3, 4, 5, 6, 7, 8, 9. T at the start, T at the end. T and T has gone. So how many left over? Nothing but what? 7 more alphabets. 7 factorial divided by 3 factorial, because for O's, which is going to be nothing but what? 840. But he's asking for probability. So which is 840 divided by, just now we got 30,240 total, which is 1 upon 36. 5 letters are selected from this one. Find the number of different selections in 5 letters, including at least 2 O's and 1 T. 2 O's, 1 T. 2 O's, it can be 2 T's. 3 O's and 1 T. then 3 O's and 2 T's. So now T's are over, O's are over. So how many I'm left over with? A, D, S, L. So which is 4. 4C2, this is 4C1, this is also 4C1, this is 4C0. So this is going to be 6, 4, 4, 1. So how many ways? 15 ways is going to be the answer. That completes this paper. See you in the next paper. Bye.